Next, let us study about the fundamental theorem of arithmetic and its application. Next question itself, we are going to apply that one. Let's go to the next question. So here there are two numbers, one is 26 and 91. So how will we start? You have to factorize first, right? You have to factorize them. How to factorize? We already know how to factorize them. So come on, let us start with the factorization. While factorizing 26, which is the lowest prime number which comes inside 26? Yes, it is 2 itself. So you can divide it by 2 and let us factorize starting with 2. When we are dividing 26 by 2, you can see 13. Oh, 13 is a prime number. Forget not, whenever you are getting a prime number on the below area, stop your factorization there itself. Means when you are getting a prime number, furthermore we can't factorize it. Means that's the maximum level that we can factorize. So here we are stopping our factorization. So we can write 26, or we can express 26 as 26 is equal to 2 into 13. 2 multiplied by 13. Okay, take the next number. It's 91. Okay, 91. In which table it's gonna come? 91. It doesn't come in the table of 2 because the last number is not an even number. It's not even a 0 also. Either it should be an even number or it should be 0 about the last number. But here it's not even a even, it's not a 0 also. So definitely it doesn't belongs to the table of 2. Checking continually, you can understand that 91, it comes in the table of 7. So let's factorize it by 7. While factorizing it by 7, what did you got? Yeah, 13. Again, another prime number. Stop it there. So you can express 91 as 7 into 13. So here we got two numbers. We factorized them. So what was 26? 2 into 13. What is 91? 7 into 13. Okay, now let us get to the Hcf and Lcm part. How to find the Hcf? What was the definition of Hcf? Just recollect. What's it? Yeah, that means it's the product of the common primes. In both of these numbers, which is common primes? Take the product of the common primes, not only the product, but it should be the least power. It should have the least power. Here anyhow, there is only one common prime, that is 13 itself. It's 13. So what about the power of 13? On both of the factorization, you can understand that it's just 13 raised to 1. I mean simple 30. It's just 13 itself. It's just 13 raised to 1. Right? So both of them are carrying the same powers. So there is nothing to worry about. Very fast you can write it as, you can conclude it as Hcf is equal to 13. You got it. Now you have to find the LCM also, right? How to find the LCM? You have to multiply all the prime numbers which you have received from these two factorizations. You have to find the product of all the numbers. But forget not one thing, while finding the product of all the numbers, you must make sure that each prime number should have the highest power. Whatever you received as a result of factorization, it should be of the highest power. That's the important point. So let us check it out here. How many prime numbers are included in these two numbers? Here you can see 2, 13. While you were factorizing 26, you got it, right? What about 91? When you are factorizing 91, what did you got it? 7 and 13. That means 2 is there, then 7 is there, then 13 is there. These are the three prime numbers which is included inside this one. So take the highest powers of everything. Here you can see in this question, everything is having, every number is having exactly the same power, that means 1. So there is nothing to worry about. Just like Hcf, very simply you can find the LCM also. How? Just to multiply them. Now let us multiply. What should we multiply? 2 multiplied by 7 multiplied by 13. 2 into 7 into 13. It gives the answer 182. So that's your LCM. Now you got LCM and now you got the Hcf also. What's the next step? We have to verify. What is the thing which we have to verify? We have to verify that LCM into HCF is equal to product of the numbers. The numbers means here it is 26 and 91. Okay, let's start it. First of all, let us check out LCM into HCF. What was our LCM? LCM was 182 and our HCF was 13. While multiply them together, what did you got? 2376. Keep it there. Anyhow, you multiply those two numbers. Now let us multiply the two numbers, means our question itself. What is it? It's 26 and 91. When you're multiplying 26 and 91, check it out. Yeah, how much it is? It is 2376 itself. That means it's verified. What is verified? So we will write, therefore, HCF into LCM is equal to product of the numbers. Means if you're taking two numbers and if you're taking the product of those numbers, that will be exactly equal to the product of their HCF and LCM. So it's verified. So we can write hence verified. Coming to the next question. What's the next question? There are two numbers again. Here it is 510 and the second number is 92. So let us start with the factorization. 510, it's an even number. So definitely it will be divisible by 2. So let's start with the smallest prime number. So here it is 2. Dividing it by 2, how much times? Yeah, let us check it out. Next, again by 3, then again by 5, then again by 17. So see here, 17 you got finally, right? What about 17? 17 is a prime number. I told you, whenever you are getting a prime number, you have to stop there itself, right there you have to stop. So here we got a prime number, so we are going to stop here itself. Now let us, how can you mention 510? We will write 510 is equal to 2 into 3 into 5 into 17. Similarly, let us take 92, factorize it. Yeah, so 92 is an even number. So we are going to factorize first of all by 2 itself. So when you are factorizing by 2, come on, let us start it. First number 4 times, then 6 times, 46, again by 2. Now, yeah, this number, see when you are dividing it by 2, how much did you got? 23. 23 is a prime number. So as it is already there inside our mind, whenever we get a prime number, we have to stop right there itself. So we are stopping here. We are finishing it here. Okay, so now let us express 92 as the prime factors. Come on, how we will write? 92 is equal to 2 into 23. That means 2 times it came, right? So here we can conclude it as 2 square. When it came 2 times, we will write it as 2 square into 23. Clear? Okay, now we have to find the HCF and the LCM. First of all, let us go with HCF. How to find HCF? Take the common primes, right? And it should be the of the least powers. Here, what are the common primes? You can see in both of these things, 2 is the only common prime number, right? In 510 also 2 is there. In 992 also you can see 2 is there. So 2 is the only prime number which is available in this one. So what about the powers? I told you we have to take the least power. While factorizing 510, 2, what about the power of 2? It is 1. What about 92? There you can see 2 square. That means there the power is 2. There it is having the biggest power. So while taking HCF, keep in your mind that you have to take the least power one. Don't select the biggest one, select the lowest one, even though the name is HCF. That's the easiest way how to understand it. HCF, highest common factor. When you're taking the highest common factor, take the least power. Just opposite. When you're taking LCM, you have to take the highest one. That's only the thing which you have to keep in your mind. Right? It's a small trick for you. Now let us go to LCM. How to find LCM? You have to choose all the prime numbers, whatever you got. How many prime numbers you got? You have to select all the prime numbers and you have to find the product of all these prime numbers. But one thing you have to keep in your mind. What is that thing? The only thing that you have to keep in your mind is you have to choose the highest powers. You have to choose the highest power. If an highest power is available, choose that one, throw another one. Right? Which is the lowest power, then just neglect it and choose only the one which is having the highest power. So check out here. How many prime numbers are there in this solution? You can see 2 is one of the prime number. 5 is another prime number, 3 is another prime number, then 17 is also one of the prime number, 23 is the next prime number. Lot of prime numbers, right? So it's very nice. We have to multiply all these things. Let us check it out. What about 2? See, while you factorized 510, you got only 2. What about 92? When you are factorizing 92, you can see there is a 2 square. So which one is the biggest one? Is it 2 or 2 square? Right? 2 square is the biggest one, right? So we will neglect that 2 and we will take this 2 square. We will never use the 2 which is along with that 510. Rather, we will use the 2 square. Why we are using 2 square? Because it's the highest power. It's having the highest power. So here, first of all, 2 square into. What's about the next prime number? It's 3. So there is only a single 3. So that's it. 3 into. What about next one? It's 5. 5 is only. It's only left there. So 5 along we will take. So 2 square into 3 into 5 into. What about the next number? Yes, it is 17. 17 is also left alone, so take it. What about the next one? 23. It's also of the base form. It's 23 raised to 1 itself. So only the first thing which you have to check means only in this 2. Among these 2, in the first one also you can see there is a 2. In the second one also there is a 2 square. So which one you will select? Only the highest one, right? So that is the only thing which you have to keep in your mind while doing this one. So now let us get to the answer. LCM is equal to what you will conclude? 2 square into 3 into 5 into 17 into 23. What will be the answer? While multiplying all these numbers, you will get it as 23,460. It's a very big number, right? Almost pretty good big number. Okay, anyhow you got that number, right? Now you got LCM, now you got the HCF. What's the next step? Verification. What should we verify? LCM into HCF. Get into that. LCM into HCF is equal to, what was our LCM? 23,460 multiplied by what is our HCF? It's 2 itself. So multiply them together. What will be the answer? Yes, 46,920. Oh, you got a very big number, right? Okay, it's okay. Keep it there. Keep that number there itself. Now what should we do? What should we verify? We have to take the product of the numbers also. What are those numbers? 510 and 92. Let's find the product of 510 and 92. Do it. Now you got it. How much it is? It's also exactly 46,920. That means it's verified. What is verified? It's verified that LCM into HCF is equal to product of the numbers. You got both of them same. Hence verified. That's all. Let's go to the next question. Here again we are getting two numbers, 336 and 54. Okay, let's start with 336. Let's factorize it. While factorizing, how much did you got? Let's see. Okay, see here, while factorization 336 you got 2 raised to 4 into 3 into 7. Means 2 raised to the power 4. Again and again we have to factorize. We were factorizing by 2. So you got 4 times you got. So we will express it as 2 raised to 4. 2 raised to 4. So now 2 raised to 4 into 3 into 7. Keep it there. Let us go to the next one. What's next? 54. Yeah. While factorizing 54, how much did we got? Check out. 2 into 3 cube. It's very nice because anyhow plenty of powers are coming and we have a lot of job to do in this question. Let's see. Now 2 into 3 cube. Okay. Keep that one there itself. Now comes the question, what is the HCF? What is the HCF? The common primes. So choose the common primes, multiply them. Forget not, the power should be the least one because we are going with HCF. Let us see here, which are the common primes? 2 is a common prime. 3 is also a common prime here, right? So there are two numbers which is coming here as common. 2 is also a common prime. 3 is also a common prime. Anyhow, we are going to multiply 2 into 3. Keep that in your mind. 2 into 3. We are going to multiply these two things. Now let us check out the powers. As it is HCF, what we have to check? We have to check the least power. Which one has the least power? Use that one. In the first factorization, you can see 2 is having the power 4. What about the second one? 2 is just having the power 1. That means nothing is written there. If nothing is written there, it means that 1 is there. Okay. So among these two things, which is the least one? The bottom one, right? The second one is the least one. So we will choose that one. That means 2 into. Just 2 into. What about 3? Here in the first one you can see, when you are factorizing the first one, what did you see? 3, just 3. What about the second question? Inside the second question you can see 3 cube is there, right? 3 raised to the power 3, that means 3 cube. Which one will we select? Definitely we will select the least one, that means the top one. So what will be the HCF? You can imagine right now, 2 into 3. How much it is? 6. You got the HCF very easily, right? This is the way how to find the HCF. Now let us go to find the LCM. Now, while finding LCM, what you have to do? First of all, choose all the prime numbers which is included in the factorizing, whichever you got by factorization, both of these things. How many prime numbers are there? 2 is there, 3 is there, 7 is there. 2, 3 and 7. These 3 are the prime numbers which we received, right? Now, what should we do? We have to find the product exactly, but keep that in your mind. What should be there? You have to choose the highest power, because here we are going to find the LCM, right? So you have to choose the highest power. Let us check it out. What about 2? Which one is the highest power of 2 in these two things? You can see 2 raised to the power 4. That is the highest one. Obviously that is the highest one, right? So we are going to choose that one. So 2 raised to the power of 4 into. What about 3? There you can see 1 3 is there while factorizing the first one. But what about the bottom one? There is 3 cube. Which one is bigger? 3 cube is bigger. So we will choose the bigger one only. So anyhow 3 cube we are going to choose. So 3 cube into, what's the next one? 7. There is only a single one. So keep it there. 7 we need. So what will be the LCM? LCM will be 2 raised to 4 into 3 cube in 2 raised to 4 into 3 cube into 7. You got it? Now, what about LCM? LCM is equal to 2 raised to 4 into 3 cube into 7. When you are multiplying these 3 numbers, what will be the answer? It's 3024. You got 3024. So now you got the HCF as 6 and now you got the LCM as 3024. Now what's the next step? Verification. Let's go with verification. What should we verify? LCM into HCF, right? So here LCM into HCF means 3024 into 6. How much it is? 18,144. 18144. You got it. So let us check whether it's the exactly same number which we are going to get when we are multiplying those two numbers. Let us check it. So what are the numbers? 336 and 54. Now let us multiply them together. Multiplying, yes, you got exactly the same number. So what does it mean? It means that the product of the LCM and HCF is equal to the product of the numbers. So we can write, therefore, LCM into HCF is equal to product of the numbers. Hence, verified. Next question. What is the next question? Find the LCM and HCF of the numbers by prime factorization method. So here, there is no verification. You have to just find the HCF and LCM by the same method. I mean, prime factorization method means express them as the as the multiples of as the product of primes, express them as the product of primes, and then from that one, from that prime factorization, you have to find the LCM and HCF. Question number 1. Here there are 3 numbers are given. The previous question there were only 2 numbers. So here it's something special. There are 3 numbers given. Let us go to the first question. What is the first question? 12, 15 and 21. 12, 15 and 21. Let us factorize them. What about 12? 12 can be written as 2 square into 3. Right? What about 15? You can write it as 3 into 5. What about 21? 3 into 7. You got 3 of them. It's so easy because already it's very small numbers. It's a 2-digit number. It's very fast. You can get that one. You got it. Now, from this one, tell me, what about the LCM and what about the HCF? Let us start with HCF first. It's so simple because just let us check it out whether there is any common prime factors. Check it out. Is there any common prime factors? Is 2 a common prime factor there? Is 2 is common? No. 2 is only there while we were factorizing 12. In other 2 numbers, 2 is not there. So 2 is not a common prime, right? Then what is the common prime? Which one is the common prime? while checking out, you can understand that 3, in 3 of them, while factorization 3 of them, you can see 3 is the common prime and you have to choose. So 3 is the only common prime. There is no more common primes inside that one. So let us come with 3. Anyhow, 3 we are going to write as the answer. And one more thing, what's that? You have to take the least power. So what is the least power? Here in this question, everything are having the same power. That's why there is nothing about the least and biggest, nothing to deal with it. Simply we will write 3 itself. So 3 is the highest common factor. That means HCF of this one. Now, what about LCM? When you are finding LCM, what was the trick? What was the method? You have to multiply all the primes. You have to find the product of all the primes which is having the highest power. That's the key point. Use the highest power one. So here, let us come with 2. That is the first prime number, right? So 2. So the highest power of 2, here it is 2 square itself. Take it. 2 square into, what about 3? The highest power of 3, it's 3 itself. So 3 into, what about the next one? 5. 5 itself into 7, right? So you brought all the prime numbers which are having the highest powers also. Now let us multiply them and find the product. Yes, while multiplying and finding the product, what is the answer? You got 420. That's the LCM. That's it. Nothing to verify. You got HCF and you got LCM. That's it. Next question. What's the next question? 17, 23 and 29. Oh, 17, 23, 29. You can feel something right inside this one. What is the key thing? 3 of them are prime numbers. 17, it's a prime number. 23, it's another prime number. 29, that's also a prime number. So how can you express it as a product of primes? Being a prime number, you already know it will be having only one factor, and that will be 1 itself. That will be the common factor. 1 will be the common factor. So how can we express 17? Come on. 17 is equal to 1 into 17. 23 is equal to, yes, say with me, 1 into 23. What about next one? 29. Same. 1 into 29. You got it very easy, right? So easy. I pray that these typical types of questions may come for our exams. It's so easy. Anyhow, you got 3 of them. But there is something very important inside this one. How to find the HCF, right? Just every time when students, they used to think this one, they will never think of this 1. They will simply think that these are prime numbers. Then from where? Nothing is common. So most probably students used to write 0. So that's why, forget not, it's not 0, 1 is common there. 1 is common. So here, if you are taking any prime numbers, how many prime numbers, it doesn't matter. If you are taking some prime numbers and if you have to find the HCF, definitely forget not, keep this in your mind, 1 will be the HCF. So here, same as it is, 1 is the answer. So we will write HCF is equal to 1. You got the HCF, right? Now, what about LCM? You have to multiply all the prime numbers having the highest power. Here, what are the prime numbers? Leave that 1 aside. Then, other than 1, what are there? 17, 23 and 29. Multiplying 17, 23 and 29, taking the product. What is the product? 11,339. 11,339. 11,339. You got it. So that's your LCM. Now let us go to the third question. 8, 9 and 25. These are the 3 numbers. 8, 9 and 25. How can you express 8? For 8 you can write it as 2 cube, right? 2 raised to the power 3. You can write it like this, 2 raised to the power 3, 2 cube. Okay. What about 9? It's 3 square, 3 into 3, 3 square. Expressing it as the product of primes, right? In powers we have to write, forget not. Then third one, 25. It's the square of 5, so 5 square. So you got 2 cube, 3 square and 5 square, 3 numbers. Now, is there anything common? Is there anything common inside this one? No, there is nothing common. What did I told you right now? If there is nothing common, what should we write? HCF is equal to 1. HCF is 1. Okay, don't write 0. It will be wrong. It's 1 itself. Now, what about the LCM? You have to choose all the prime numbers and select the highest powers. Come on. So here, what are the prime numbers? 2, 3 and 5 are the prime numbers. What about 2? The highest power of 2, it is 2 cube itself. The highest power of 3, it is 3 square itself. The highest power of 5, it is 5 square itself. So we will write 2 cube into 3 square into 5 square, right? So that means 8 into 9 into 25. By multiplying all these numbers, you will get 1800, 1800, 1800. You got it. So that's your LCM, and your HCF is 1 itself. This is the way how to find HCF and LCM of any numbers by using the method of prime factorization. Hope you understood and enjoyed the class.